Hi everyone, in this video I am going to talk about bond line structural representation of organic compounds. So we are going to represent organic compounds in the form of bond line structure. Okay, so let us start here. Bond line, we are going to show only, we are not going to show the carbon and hydrogen here. Okay, so we'll learn with this example. Okay, we'll see with this example. So here what is it? This is the name of a compound. This is 3-methyl octane. Okay, 3-methyl octane. So how to write this compound? Okay, this is the name of a compound. Then how to write the formula here? So you just need to see is the last one, oct. Okay, octane. So the last one is octane. So when it is the word root is oct, then we know that the number of carbon chain is okay, carbon chain is 8. Okay, so whenever you see this last one, it is pentane, octane, hexane, we always will know through this word root. Okay, oct means 8 carbon, ane means all are single bonded, so we will directly write 8 carbons by putting single bonds. Okay, so 1 2 3 4 5 6 7 8. Okay, so 1 2 3 4 5 6 7 8, done. Now it is what? 3-methyl. So this is your main chain. So your chain contains what? 8 carbon. Now this is your substituent. This is the prefix one. That means the front one is your substituent. Substituent means that is out of the chain is called your substituent. Okay. So 3-methyl. So 1 you count from here. 1 2 3. So in the 3 position, in the third position it will be your methyl. Methyl means only 1 carbon. Okay, methyl, CH3, methyl means CH3. Then our part is done now. So let us balance the carbon with hydrogen. CH3, 3 with this bond 4, 1 2 3 4. Okay, we have to balance 4 carbon. Valency, that means carbon has 4 valency, 4 bonds should be there. 1 2 3, then 4. So 1 2 with this 2 4, 1 2 3 4. Okay, so I have taught this in my earlier videos also. Okay, then CH3, this part is done to you. Now here we have represented the formula here. Now we can also represent this in the form of this way. See, the CH3. Okay, I can just put this one this way. First carbon, second in the zigzag form. Okay, second carbon. Okay, then I'll bring in the third carbon here, CH. Okay, in the third position there is what? CH3. Then what third has done? You just be aware how much carbon has gone. 1 2 3 has gone. Fourth, fifth, 6 7 8. We have done this. So it can be written in this form, zigzag form. Okay, so in this form. So this, see, this junction, that means there is carbon here. The two lines are joining intersection, carbon is present. The terminal, carbon is present. Okay, here ending are always carbon. Always the meeting point, two line meeting points, that is the junction or intersection, is carbon. Okay, so these are carbons, these are carbon, these are carbon. Now in the bond line structure, right? So in this bond line we are not going to show any of this carbon or hydrogen, so we can write in this form. See, this, okay, this, okay, then this. Okay, so this is what? 1 2 3, count in this way, 1 2 3 carbon. In the third there is CH3. So we are not going to show this carbon hydrogen. So 1 2 3 4 5 6 7 8. So this is called the bond line structural representation of organic compounds, where we are not going to show the carbon hydrogens atom here. Okay, so see, this ending, so student must remember what is this. Here you should remember carbon is present, that is the methyl one, that is also CH3. Here it is what? CH2. Okay, CH2. So ending are always, terminal are always CH3 in the bond line representation. Don't think that this is hydrogen, this is always carbon, that is methyl carbon. Terminal are always methyl. So this is the bond line structural representation of any organic compound. Okay, let us try with another one. You can just take a random formula. Okay, name of a compound. Let us say, let us do with okay, of your own choice. We have taken 3-methyl, so you can take with 4-methyl. Okay, 4-methyl. Then instead of octane, you can take another one, hexane. Let's see how it works. Okay, now see, hexane. By this last term, we will understand how many carbon chains it includes. Okay, initially if you're you will feel difficult to draw this one, or if you are able to draw, that is also I'll show you the way here. How many hexane? Hexane means how many carbon? So you can draw in this way. See, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. Okay, so you can draw in this way. So how many carbon? Hex means it is 6 carbon. Okay, 6 carbon. So 1, 2, 3, 4, 5, 6. Done. Where is your methyl position? The methyl position is in the fourth one. So 1, 2, 3, 4. So you can write like this. Okay, so so this is just to make you understand. I have done all this, have shown all this. So directly now you can write in this form. Okay, so let's try another one, like let us write buta 1 2 diene. Okay, now we don't see, now it directly start with the word root, so there is no substituent at all. There is no prefix, that means there is no substituent. There is a single chain. Okay, whenever before the word root anything is there, this is called word root. Bute, hex are called word root. So before the word root, any words are there, that is your prefix. That means your chain is not a straight chain, it will be a branch chain. Now your word root starts, that means we have a single chain, no substituent. Okay, so bute means how many carbon? Bute, all of you must know this one first. Okay, bute means 4 carbon. Okay, 4 carbon. So we will write it 1, 2, 3, 4 bute. Done this part. But here it is not single bond. Okay, it is not single bond, it is in. It is in, it ends with in. That is also di. Di means 2, in means double bond. So there are 2 double bond, diene. Okay, so in which position is your in? In the 1, 2 position. So it will be wrong. See, if I put 1 here, okay, so it should be 3. Okay, it should be 3. So 1 in the 1 carbon, double bond is there. 2, 3. After 3 you will put double bond. Okay, so this is also the bond line representation. Okay, so this is in case of double bond. So in this way you can make your own formula, you can make your own compound just randomly. Okay, for practicing. So let us write another one. Okay, 2-ethyl. Let us say 2-ethyl. Okay, let us say 2-ethyl sorry, okay, 2-ethyl pentane. Okay, let's start with the simple one, then we will go to the tougher one. Okay, tough one. So now we will see the word root. What is this word root? Pent and ane. That means it is single bond, right? So it is single bond. So pent means 5 pent. The word pent means it is having 5 carbon. Okay, it is having 5 carbon. And ane means single bond. So let's start. You can start in this way, or I have always started with this way. You can start from the upward also. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. So 1, 2, 3, 4, 5 carbon. Now before this word root, pent, bute, hex, okay, oct, before this one word is there here, some words are there, that is called your substituent. That means there will be a branching. Okay, that will be out of the chain. So ethyl, so ethyl means what? 2 carbon. So it is in this way. If it is 1 carbon, we will write here ethyl means this one. Okay, so 1, 2 carbon. So we can write in this way. Or if you okay, I'll show you to make you more clear. So pentane means what? Right, pentane means what? 5 carbon. So 1, 2, 3, 4, 5. You can for initial practice you can do in this way. Done. 5 carbon has done. Now in the second position, 2 position, that is what? Ethyl. So ethyl you can write in this way or upward direction. Let me write here. So it means how many carbon? 2 carbon. So 1, 2. Okay, so we'll balance it 1 2 3 4. You balance it always by hydrogen. This should be done. Okay. Okay, done. So now see, we'll balance it by hydrogen 1 3 4. Okay, you check my earlier videos that there I have taught you how to balance it. Carbon has always 4 valency, so it will be balanced by hydrogen. So this part is done. Okay, after that you can write in this form. Okay, someone can write in this form also: CH3 first carbon, second carbon, third carbon, okay, fourth, fifth. Okay, now in the second position what it is there? CH2, then CH3. Okay, now well if you want to draw it in the form of bond line structure, see, this is carbon, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Now in the second position, what it is present? Okay, what it is present? Ethyl group. If I write straight way, it looks like methyl. If I just write straight, then it will look like methyl. Since there are 2 carbon, there should be in this way. Okay, this way. This indicates 2 line joining, indicates always carbon. Okay, so you can write in this way or you can write in this way, both are same. Okay, so this is your bond line structure. So you can write in many forms. Okay, yeah, like if I write in this way, say CH2, another structure. Okay, another structure, CH2, 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 CH2. Have done this. So write in the bond line structure, you can write bond line structure. So you can write this carbon. See, carbon. So carbon, carbon, carbon. Okay, so even you can write in this. Okay, so you can practice it to make more interesting. You practice yourself 10 to 20 questions. Okay, so if I write in this way, how many carbons are there? Let us write. Okay, CH2 in this way. How many carbons are there? 1 2 3 4 5 6. So you start from here: 1 2 3 4 5. Okay, see, let us count: 1 2 3 4 5, then with this 6. So these are bond line representations. Okay, here we are not going to show carbon hydrogen's bond, but if any heteroatoms are present like oxygen, nitrogens, then we have to present it. Okay, if any heteroatoms are present, we have to represent it. Like if I say if I've written in this way, okay, I have written in this way, then we have to represent this oxygen atom. We are not going to show that is only carbon and hydrogen. Okay, so we are going to show the heteroatoms, that means other than carbon and hydrogens. So in this way you you make your own formulas, you make your own structure, and see it's become very interesting. Okay, so just you take a simple compound like butane. You start with the simple one, like those who feel difficult, just start with the easy one. Ethane. So ethane means how many carbon? Just 2 and CH3 bond 2 carbon. It means 2 carbon. Ane means single bonded. So CH3 CH3. So how to draw it in the line form? You will just draw in this way. Okay. Then let us go for propane. Propane. So propane means prop means how many carbon? 3 carbon. So I'll draw it 1 2 3. So balance it. We will balance it. How to draw it in the form of line? So you can start upward or you can start downward, no problem. Okay, so 1 2 3, done. So this methyl, this CH2. So start with the easier one like butane. Okay, butane. But means 4 carbon. Okay, but means how many? 4 carbon. So right, directly you draw in this way initially, those who are at the beginners. Okay, 4 carbon we have drawn it. Valence it, carbon should have 4 valency, 3 4, 1 2 3 4. Okay, CH3. So how many carbons? 4 carbons. So 1. So 1 2 3 4. So in this way. Okay, you want to add more complex, you want to change the structure, just we'll add some substituent. 2. Okay, we'll start with easy one, methyl butane. So you will see butane means how many carbon? 1 2 3 4. Butane means 4 carbon. In the second, okay, this is your chain now. Before that there is a prefix, that is your substituent. In which position is your substituent? In the second. 1 2. So methyl. So this 3. Balance the carbon. Okay, So how to write the bond structure bond line structure? How many carbons? 1 2 3 4. Just count 1 2 3 4. So 1 2. So 1 2 3 4. Done. In which position is your methyl group? In the second position. 1 2. Okay. So this is your bond line structure. Okay. So these are easy. Okay.